Hello, Coach Travis here with another calculus video. So what we've got here today is a particularly nasty derivative problem. So this is kind of going to be algebraically a lot of work, but I wanted to do at least one of these just to show you that if you stick with it and you hang in there, you can get through these things. So what we've got is this fourth degree polynomial function, s of x, and we want to find the derivative of s, and we want to use the limit definition of the derivative to do that. So before we do that, I want to review, the algebra is going to get really heavy in this problem. And so before we actually start doing the problem, I just want to review a few algebraic facts. So let's see here. So like what I want to review is what the technical name for it is the binomial theorem. But it's like if you have an expression like x plus h, so the expression x plus h is going to come up when we use our limit definition of the derivative. And I hope you know from experience that when you have x plus h and you square that whole quantity, you have to do FOIL, right? You have to do x plus h multiplied by x plus h, and then you have to do FOIL, and when you do FOIL there, you get x squared plus 2xh plus h squared. Okay, so I hope that looks familiar to you. But what we're going to have to do in this problem is we've got something to the third, we've got x cubed, and we've got x to the fourth. So when we use the limit definition of the derivative, we're going to end up with an x plus h cubed at some point. So again, I haven't done it yet. So if you're wondering, wait, where is this coming from? It's not clear where it's coming from right now, but trust me that this will come up when we find our derivative. So what we want to do is we want to be prepared for that. We want to be able to know, well, what is x plus h cubed? And okay, well, x plus h cubed is going to be, well, basically it's going to be x plus h times x plus h times x plus h. It's going to be 3 of these instead of just 2. Or another way to think about it is it's going to be one more x plus h, and I can multiply it by this because I know that this is actually 2 copies of x plus h. So I could do x squared plus 2xh plus h squared. And now you have to do, well, you have to do sort of super FOIL. It's not quite FOIL because there's going to be actually 6 things, but you'll do x times x, and that makes x cubed. And then you'll do h times x squared, but then there'll also be you'll get an x squared times h when you multiply these two. Right, when you multiply this guy and this guy, you're also going to get an x squared and an h. And when you multiply these two guys together, you got an x squared and an h. And then so anyway, long story short, if you do all the FOIL here, if you do all six of the FOILs, what you wind up with is x cubed plus 3 times x squared h plus 3 x h squared, and then plus h cubed. And okay, and then now this problem is really nasty. Well, wait, let me back up. Before I go ahead, make sure that makes sense to you. make sure that you understand where all those terms came from. So the idea is I'm going to do this times this, and then I'm going to do this times this, and then I'm going to do this x times this h squared. And then I'm going to repeat the whole process, but with the h. I'm going to do h times x squared, and I'm going to do h times 2x plus h, and then I'm going to do h times h squared. So you're going to wind up with 6 terms. And when you gather up all the like terms, this is what you'll wind up with. So make sure that you can do that. And if you can't, send me an email or something, and I can show you some more steps. Okay, so that's when we have an x plus h cubed. But this problem, it now has an x to the 4th. So, oh boy. So we're going to have to trust me that when we use our limit definition of the derivative, we're going to wind up at some point in the problem, we're going to wind up with an x plus h to the 4th. And so, oh my gosh, so that's going to be a real mess. So basically you're going to have to do x plus h multiplied by all of this now. X cubed plus 3x squared h plus 3x h squared plus h cubed. And so, okay, and now again, so you have to do a sort of a super foil here. You have to do x times this, and then 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 you have to do h times this, and h times this, and h times this, and h times this. So you wind up with like 8 terms. But then when you gather up all the like terms, what you wind up with is you'll have an x to the 4th, and then you'll have a plus a 4 x to the 3rd h, and then plus 6 x to the x squared h squared, and then plus 4x h cubed, and plus h to the 4th. So when you do this, you're trusting me right now. That what you really need to do is you should pause this video and go through this multiplication step by step, and confirm that you do get this. But if you go through all that algebra, you should wind up with this. And actually, while I'm at it, you might wonder, well, gosh, Travis, how did you do that so fast? You must be really smart. No, I'm not really that smart, but I do know things. And one of the things I know is I know the binomial theorem, and you might have seen this before. There's this thing called Pascal's triangle. It has a 1, and then a 1 and a 1, and then you get the next number, and then like a 1, a 2, and a 1. And so the idea is the number that goes here is the sum of the 2 numbers that are above it. So like there's nothing here, so nothing plus 1 makes 1, and nothing plus 1 makes 1, and 1 plus 1 makes 2. And so I can make another row of the triangle, like 1 plus 2 makes 3, 2 plus 1 makes 3, 1 plus nothing makes 1, and 1 plus nothing makes 1. And here's this triangle goes on forever. You can keep making it, but nothing plus 1 makes 1. 1 plus 3 makes 4. 3 plus 3 makes 6. 3 plus 1 makes 4, and 1 plus nothing makes 1. And so Pascal's triangle is a pretty cool thing. But what I want you to notice is that look at these numbers. 4, 6, 4, and they're invisible ones here and here. So the coefficients of these terms are exactly the fourth row, or I guess it's the fifth. It's exactly this row of Pascal's triangle. And this guy right here, there's what, an invisible 1, a 3, and an invisible 1. And that's exactly this row of Pascal's triangle. And up here, invisible 1, 2, invisible 1, that's exactly this row of Pascal's triangle. So the fact is that the coefficients, that's why I was able to do this so fast. I was able to do this so fast because I know Pascal's triangle, and I know the first few rows of Pascal's triangle, and so I was able, I was able to do that. And so the fact that the coefficients here are the same as the numbers in Pascal's triangle, that's known as the binomial theorem. And so you can look that up if you want to learn more about it, but it is really cool. Okay, so the point is now what we wanted to know out of all this was we're going to need to know this, and we're going to need to know this when we do the problem. So hopefully you have those written down in your notes. So that is, we need to know that x plus h to the fourth is equal to this terrible thing, and x plus h to the third is equal to this slightly less terrible thing. So we're going to need to know that, but I hope that you understand why that's true now, and then now we can actually start answering the question. Okay, so let's get rid of all this. Okay, so yeah, so that was all just a preliminary stuff. So I want to admit we haven't started actually answering the question before now, but now we will. Okay, so let's start answering the question. So, all right, so I'm going to use it says use the limit definition of the derivative. Okay, so the limit definition of the derivative says s prime of x is equal to the limit as h goes to 0 of s of x plus h minus s of x divided by h. Okay, so that's straight out of the book. That is the limit definition of the derivative that you should have memorized. Okay, so now what we do is now we substitute. We say, well, okay, well, what's s of x and what's going to be s of x plus h? So this is going to be now, let's see here. So this is going to be the limit as h goes to 0 of, and now this is going to be an enormous fraction. And it's still going to have h in the denominator. So the denominator is going to be nice and simple, but the numerator is going to be really, really bad. Okay, well, so let's think about what is s of x plus h? Well, okay, well, let's think about what s of x is. So it like takes the input and it raises it to the fourth power and it multiplies it by 3. And then it adds 2 multiplied by the input cubed. And then it adds 3 multiplied by the input. And then it adds 5. Okay, so actually this fraction's even bigger than I thought it would be. It's going to take the whole screen because I'm not even done. So, okay, so, but what am I trying to do here? What I'm trying to do here is I'm trying to figure out what is s of x plus h. So s of x plus h, well, it's exactly what you get here, only everywhere I see an x, I'm going to replace it by x plus h. So that's why I kind of wrote it like this, because now the idea is those blanks represent the input. And so since in this case the input is x plus h, I'll have an x, I can put an x plus h there, I can put an x plus h there, and I can put an x plus h there. So that, and now, oh, and in fact, and then maybe I'll put this in big parentheses here. This right here is what s of x plus h is. So this big complicated thing in the blue parentheses, that is s of x plus h. Okay, but now, don't forget about this though. So now I have to subtract something. I have to subtract s of x. Okay, well, s of x happily isn't such a big deal because, I mean, s of x is just right here, sx. So, okay, so we got, this is just going to be 3x squared, no, sorry, x to the fourth. 3x to the fourth plus 2x cubed plus 3x plus 5. Okay, so that is, that's just s of x right there. Okay, so the idea is this thing expands to this big thing, and this little thing expands to this slightly bigger thing. Okay, so now you can see why we did that preliminary work. Because in that preliminary work, we need to expand what we're going to have to do next. And I don't even know if we're going to have room on the screen. We have to expand this. And we have to expand this. And then, so basically we have to just do a whole bunch of algebra to simplify this whole numerator. And that's going to be a real mess. So I'm going to go ahead and expand that, but you don't necessarily need to see me doing that right now because it'll just take too much time. So anyway, when I'm going to pause the video, but when I come back, this will be expanded a little bit and we can talk about it. All right, I'm back here. So magically, what just happened is these expressions just popped up. And what these are is I'm expanding this. So I want to know what's 3 times x plus h to the fourth. And I also want to expand this. And so I want to know what is 2 times x plus h to the third. So, okay, so 3 times x plus h to the fourth is, well, that's 3 times all of this stuff. So remember at the beginning of the video when we talked about the binomial theorem, we expanded x plus h to the fourth, and we said that x plus h to the fourth expanded to this when you do like that super FOIL. So this is going to be equal to 3 times this big thing. And now the next step is to distribute that multiplication. So everything in the parentheses gets multiplied by 3. And so you wind up with this. And you can pause the video and check that out for yourself. And now, and we do the same thing down here. X plus h cubed. When we use the binomial theorem like we did at the beginning of the video, x plus h cubed expands to this thing in parentheses. And then we have to multiply by the 2 because we have a 2 right here. And so everything in the parentheses gets multiplied by 2 and you wind up with that. So what I'm going to do next is now I'm going to rewrite this limit. But now when I rewrite this limit, these things are going to be expanded. And we'll see if that fits on the screen or not. I'll try my best. Okay, so we've got this whole thing expanded. So the idea here is that this piece, right, maybe I'll underline it here. Let me try to color code it. This green thing right here expands to this green expression here. And this, I guess I don't have a good color here. This expression right here expands to this expression right here. So maybe I'll try, yeah. Let me get that. Let me highlight this in green. All right, so this green expression expands to this green expression, and this, I don't know what color that is, this expression expands to this expression that I wrote using white pen right here. And then what else is here? This, okay, 3x plus h, this is pretty easy. If you just distribute the 3, then you get 3x plus 3h. So this little expression is represented right here, and then the plus 5 and the plus 5. So this all expands to this monstrosity, and then this guy is the same as it was before. So, all right, so slowly but surely, we're making our way through all of this terrible algebra. But now what I want us to see is now we're going to start getting some cancellations. So I think the worst part is over. So let's see what's happening now. Here we have a plus 5, and here we have a plus 5. Oh, but wait, but it's a subtraction. Everything that's in this second set of parentheses is being subtracted. So this is a plus 5, and this basically is a minus 5. So these can knock each other out. Those make 0. And then what else? Here's a 3x, and here's another 3x. Oh, but wait a minute, it's in those parentheses with the minus sign. So that 3x can knock out that 3x. And let's see, what else have we got here? What do we have here? Oh yeah, here's a 3x to the 4th. And here's a minus a 3x to the 4th. So great, so those guys make 0. And lastly, here's a 2x cubed. And here's a 2x cubed. Oh, but wait a minute, it's in the minus parentheses. So those will knock each other out. So we got some cancellations there. So all right, so I'm going to go ahead and pause the video and rewrite this limit, but with the deletions taken out. Okay, so now what we've got is if I get rid of all the stuff with that made 0, what I'm left with is, okay, I'm left with this green stuff, which is all right here. And I'm left with all this, I'm left with this white stuff, which is written right here. And I'm left with the 3h, the yellow 3h, which is right here. So after I'm done simplifying this numerator, this is what's left. And okay, so the thing you want to notice about this is that, notice there's a common factor. Every one of these terms has an h in it. Every single one of these terms has an h in it. And that's actually a very good thing because we can factor an h out of the numerator. And look, there's an h in the denominator. So we'll get a nice cancellation there. So all right, so once again, I'm going to pause the video and take care of that. And when we come back, you'll see it. Okay, so we're almost done. Okay, so I'm going to be working from the bottom upward here. So this is where we just were. And so what we noticed was that every term in the numerator has an h. So we factor that h out. So we factored an h out of every term in the numerator. So when we factor an h out of this term, it's just going to be 12x cubed. When we factor an h out of this term, it's going to be 18x squared and just times an h, because there were two h's, but we factored one of them out. So when you do that factoring, when you factor an h out of the numerator, this is the expression that you get. And then, okay, well now there's a factor of h in the denominator and a factor of h in the numerator. So those can make 1. H divided by h makes 1. So the h's might as well not even be there. And so that gives us this expression right here. So we don't have a fraction anymore because the h's turned into a 1. And now we have this expression. And okay, and now what do we do with this? Well, at this point, it's safe to plug in h is equal to 0. Because notice back here, it wouldn't have been safe to set h equal to 0. Because if you set h equal to 0, it's easy to see that you'll get 0 divided by 0. You'll get a 0 in the numerator and a 0 in the denominator if you set h equal to 0. And whenever you get 0 over 0, that means you need to do algebra to simplify the problem. But if I set, let's see what happens if I set h equal to 0 in this. So if I set h equal to 0 in this expression, well, nothing's going to happen here because there's no h. You know, it's h that's going to 0, not x. So this is going to stay where it is. But this guy is going to turn into 0 because that h is a 0. So it's gonna knock out that whole term. If h is equal to 0, that guy is gone. If h goes to 0, that guy is gone. Similarly with that one and that one. So all those, when h goes to 0, all of the pieces with an h are equal to 0. And so what are we left with? So what we're left with is the 12x cubed. And we're also left with the 6x. And we're left with the 3. And that is it. We've actually done it. So I think that terrible problem is finally over. We found the derivative. We used the limit definition of the derivative, and we got this as our final answer, and that is correct. So, woo, that was a lot of work, but it worked. It was a lot of work, but uh-oh, wait a minute. Oh no, I see a mistake. Oh no, I see a mistake. Okay, but it's an easy mistake to fix, thankfully. This should be squared. I'm sorry I made that mistake, but see, okay, because where does this term comes from this term, but we factored an h out. So that should be an x squared. And as soon as that's an x squared, that should be an x squared. And that should be an x squared. Okay, I'm very happy I noticed that because it would have been terrible to do this whole problem and wind up with the wrong answer. But now we got it. So I can confirm this is definitely the right answer. And we did it. So I'm gonna stop there because that was a lot of work.